Hi, I'm Lauren Selden, and today I'm going to show how to fabricate a hollow construction frame ring. So here we can see one that is finished, but it's going to go through multiple stages throughout this fabrication process. So let's do this. So when making a frame ring, my best piece of advice would be to treat it like it's a cookie cutter. And so you make the outside shape first, and then you can pop the top and the bottom on it. And so for this particular one, I want just a basic circular frame. And I'm going to ask that this one is going to be 38 millimeters for the outer diameter of my circular cylinder, my cylindrical form. And so we are working in metrics here. So the way that I'll do the math is that I have already just designated 38 millimeters is going to be my the diameter that I want to get. So I'm going to take that times 3.14, so that's for pi. And then because it's thickness of metal, I'm going to subtract 1 times the thickness of metal. And so in this particular case, that is 1 millimeter. And then we'll get our final calculation here. So I am going to grab my calculator, and that will be 118.32 millimeters. I'm not worried about the 0.32 because I'm going to be making it by hand anyway, and I can stretch things as I need to hammer. So as I go through on the metric side of my ruler, just in case if we don't remember, I am in the States. And so we have our 1 centimeter, so that's 10 millimeters, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. And then I'm trying to get to 118, so I go to 111, 115, 118. It will be right here, right before 120. Okay, so I'm also going to designate that the thickness of this isn't going to be very wide. We're just going to do this as one, and I usually will use a finer marker for this or a scribe. The thickness of it is going to be 1 centimeter. And so I am going to go ahead and cut that on the shear, and that'll be my next step. So I have videos for using the stomp shear, but I figured I could just show you quickly this little bench shear. It's a really great tool. First I'm going to grab my square and mark. Again, you can mark with a scribe to get it more precise. But there's my mark. I've already checked to make sure that my right angle here is straight, but I can check again on the line just as it comes off of the shear edge, and then just a simple cut there. And this is a great tool that gives you a really sharp edge. Next thing that I'm going to do is I'm going to file this edge because there is just a little bit of a ridge there that will show up whenever you solder. So I'm just going to file this edge flat, and then I'm going to go anneal the material. So I have the metal cut and I filed both of the edges flat, and so now I need to anneal it. Annealing is heating it up to the prescribed temperature in order to soften it, but it's actually affecting the crystalline structure of the metal. And so we can do this by eye, especially with copper. You can look for color changes. The other thing that you can do is you could take a little bit of paste flux, and I have a little on this paintbrush, and I could put it at the top of my metal, and then it'll start to look glassy whenever the metal is annealed. So I'm using acetylene air torch, and make sure that you have your ventilation on and that you're taking all the proper safety precautions. I'm going to take my striker and strike from the top or from the side, and then I just kind of have a reducing kind of bushy flame, and then I'm going to act like I'm spray painting, and I'm going to keep my torch the same distance away from the metal. You see that I have it up on a half of a soft brick, and that's just going to allow me to get all the metal the same temperature. And so you can see I'm already at a color change, hopefully you can see, where I kind of went to a rainbow colors. And then everything will all get to be about the same color, so it's kind of a light, like a dull gray, And then you can see my flux here is starting to get what we call glassier. It looks like a mirror. It's really, really shiny. And you can also see that the flame hitting off of the metal starts to be bright orange. And that's also a good indicator of it being annealed. So I'll go ahead and turn off my torch. I have a quench bucket nearby, but it is worth just kind of stalling for a second, because sometimes if you do quench metal too fast, you can create little bitty fractures. So stall for a second and then quench, and then I'll put it in the pickle to clean it. So I have the piece of metal out of the pickle. It's nice and clean. I used some pumice to clean it. There's a billion ways to turn this into a cylinder. This is just one of them that I like. I have a little stake here with a nice straight edge. And so I like to knock the piece off the edge and then hammer down. I do make sure that I'm not going straight into the edge because I don't want to dent the other side. But generally, if I can straighten out the piece and work harden it a little bit, it makes it even easier to then bend into form. And then with something this big, I would just bend it by hand. You can certainly use a stake and you can work it down to straight. But that's a great way to do it, just like that. And so now it's formed. I might, hit it a couple more times just to make sure I have it nice and straight. If I did a bad job on my filing, then I'd have to go back in with the saw blade or open it back up with a file to make sure that that line is seamless. And so now I need to solder that joint. A bunch of different ways to set this up to solder the butt joint. The joint is here. I like to put it on a soft brick, and I've made it level by putting a piece of pumice underneath it. You can do this where it's sitting down and have gravity pull the flux down. There's just numerous ways to do it. I didn't overly work hard on it whenever I formed it. If I did, maybe I would want to anneal it one more time to just make sure that it stays where it's at and your joint doesn't end up overlapping. So I've cut up a couple of pallions of hard solder. And so remember, we go to hard first, unless you need to use extra hard solder for some reason. But this is going to melt at 1425 degrees Fahrenheit. And so I just put a couple of pallions there. I usually leave my solder around just in case if one falls off or if I need to add another one. And then same thing, I'm going to strike from the side or the top. And I am going to start by preheating. The preheating, I can also preheat the bottom of this a little bit aggressively, and then that can start to get that heat around. But I'm really just looking for the water to start to boil off of the flux, and then I can start addressing it with pretty even heat. I use a solder poker to make sure that those pallions are exactly on that joint where I want them, and then I'm really heating under here, which is why I like setting it up this way. So I'm going to the bottom to get it the same temperature. The metal needs to all be the same temperature for the solder to flow. So I'm going over the top. I'm going to do one more time. Now you can see that flux is getting really glassy and that solder's ready to go. So I can either go underneath like this and pull it through, or I can go straight along the joint at the top. It's not quite ready yet. And so all that solder flowed, and I often like to knock it over and use gravity to pull it back through one more time, just so I know for sure that it's all the way through. Okay, so the outside edge of the hollow construction ring is done. And now I need to pickle, clean it, and then I'll form it. And so we have our piece, and then now we need to form it again. Again, I'm using a stake here, and I'm just looking for the curve of the stake, and hoping that it's just a little bit smaller than the diameter of my ring. You can also use mandrels of various sizes or anything that you have that you can round it out. And as I hit, I'm using a rawhide hammer that doesn't have any lead in it, so it's not very aggressive. And currently I'm hitting, roughly straight down, but I can also still do those planishing blows where my hammer sweeps off of the side of the mandrel. And you see that I have overlapping blows, which is creating a rhythm to my hammering. And I did pull out a circle template so that just in case if I can't see where I'm off, I could look at the circle template and I could get a better idea. Okay, so the outside edge is created, and now I need to file and sand these edges so that I can put a base on. So if you did the right preparation when you used your shear and whenever you measured, you really don't have a whole lot to sand. And so this is the part that everybody doesn't love, but we've made a little sanding board. I wouldn't suggest taping sandpaper directly to your table because you'll have sticky stuff forever. So we just have this piece of wood that we just always have sandpaper taped to. So grittiest is here, and then it gets and while I'm here, I'm going to do both sides. And I just have even pressure pushing down on the whole ring. And if you're doing it right, the metal should be getting hot because it's conductive and we're sanding it. So you should be able to feel that. And then everything looks nice and flat. So I'm ready to solder our base to it. So now is a good time to go ahead and anneal everything and to prepare the bottom piece. You need the piece of metal to just be a little bit, have a little bit of an edge so that it solders properly. So I went ahead and made both of my top and my bottom piece. And then you can see that we've got the cookie cutter cylinder is in the middle. So I'm gonna go ahead and just anneal all of these so that they are ready for the next step. And this one is copper, so we'll be able to see the color change a little bit better for annealing. And so there's that really rainbow. It's gonna all get about the same darkness of a dark gray. And then we'll be able to see that flame getting a little bit orange off of the edges where you can see it there, and that's annealed. And then I'll go ahead and anneal the tube that I just made, and I'll anneal the other plate as well. Both of those will go in the pickle, and then they'll clean, and then I'll be ready to solder the base and the inside tube. This is a great time to use pattern metal as well because it's going to be on the full outside of the cylinder, and so you can have pattern or etched surfaces on that outside flat surface, which is really great. You see that I'm just kind of working all the way around that tube, and I'm just going to make sure that it's nice and ready to be soldered as well and doesn't want to warp. And then I'll do the last one. It is hot, so I didn't get close to it, but make sure that you use your tongs to lay that down. I have multiple elements that I prepared. This is just a piece of sheet metal that is a little bit bigger than the cylinder, and I want to keep it as close as I can so that I'm not wasting a bunch of heat on bigger piece of metal. So I could even cut these corners off if I want to, so that it's even easier. And then I pre-cut a hole in the middle. That's going to help me measure because I'm going to actually put my hollow construction for my hollow construction ring. I'm going to put the circle in the middle, and this will keep me close. But also, I've also left some room to be cutting out with my jeweler's saw afterwards. So I'm getting ready to solder this. So just in our setup, I'm using some cotter pins that I've already carbonized, and you might have seen that in some of the other demos that I've showed. If I don't have those at home already prepared, I sometimes use the honeycombs that are broken up, and I'll use those to sit something up just in a way that it doesn't warp or, you know, get messed up. And then I'm going to go ahead and flux. I'm using fluoride-free paste flux, and I just put a little bit of water in it so that it was, it's kind of like mayonnaise or frosting kind of texture. And then I'll put that cylinder on. I'm going to get some flux on those edges, and I'm going to go ahead and flux my tube that I've already cut, and I've cut and sanded that down so that it'll all be nice and even. And then it's going to be putting on solder pallions. So I'll either do that with tweezers or with a solder poker. I am going to go ahead and use hard on this again. If I was worried about hard solder, if I was worried about the previous butt joint breaking open, I could white out that butt joint, or I'm just going to be conscientious of it whenever I'm soldering so that I don't put too much heat on it. And so I'll do this in a second. I'm going to also put solder pallions on the outside of this tube. So I have my flux on the whole thing. I have solder pallions on this outside wall, and I also have solder pallions on the outside wall of the inside tube. That is going to ask capillary action to pull it straight to the inside, because the heat's going to want to go to the inside. So I'm going to use 2 torches here, just so that I'm able to heat the piece evenly, and I want to do it fast enough so that the work doesn't oxidize. So I'll light my first one, and I'll light the second one from the side of my first one, and then I'm just going to preheat. So I'm heating around the piece, and because I have 2, I can heat it like this. If I want to use the rotary, I could also heat like that. If I don't happen to have 2 torches, I just like to use 2 torches on those things. And then anytime I need to use my solder pick or something like that, I can put down the one in my right hand. And so I'm really trying to make sure that I'm getting it heated up. I am going to move one of the pallions. I don't want to have to be messing around with solder too much, because it will get to a point where you've got it you've had heat on it too long. And I just, of course, I moved that a little bit, so moving it back. That's the negative of chasing down pallion. So I'm going to go ahead and heat it kind of aggressively, get the inside really well, and then once I want that solder to flow, I like to put my one torch to the inside. So if I'm going to get this inside wall, and then the other torch is to the outside wall. And so here I'm doing the same thing. I am going to avoid that hitting with extra heat on that previous joint, because I did use hard solder. So there's that previous joint, it kind of skipped, and there, that's just a perfect seam. Give it a second, quench it in water, back in the pickle, and then I'm going to have to cut off the bottom outside area and the inside too. So I have the base soldered and I have the inside tubing soldered. I went ahead and drilled holes in the external part of my piece. You do need a way for air to escape if you're going to keep soldering it. So to make a fully hollow construction, you're going to probably want some holes in it. Ideally, you want this to feed into your design. So maybe that's going to be something that cold connects through here later, or stones that are set in, or sometimes I'll put holes on the inside tube, and so then you're not really viewing them. But most of the time, it's built into the design, and I have some cold connected thing that's going to go through that space. But the holes are going to help you. One, if you need to solder, you could blow up your form if it's a hollow form. The next time that you approach it to heat, once it's all the way sealed. But you also need a way for pickle to escape. So if you have soldered it fully shut and there's no holes, and you know for sure that you soldered it shut, as long as you don't approach it back to heat, you don't need the holes. But if you go to put it in the pickle and you see a little bubble come up, it means that there's water or the pickle or acid that's getting trapped in there. So you're going to need a lot of holes to get it out. So generally, if you can figure out a way to get it in the design, having holes in it, hollow construction form is easier. And so for now, I am just going to go ahead and start cutting off the outside edge. I am not cutting it all the way next to the joint, because this is going to protect, it's going to still protect my previous solder seam. So I don't want to file it clean or anything. I'm just going to cut it off so that it's close. That's going to help me line up the other side. And it's going to help with the heat as well. Because depending on how big your hollow construction pieces get, the more heat you need. And I'm going to also go ahead and pierce through here, and I'm going to clean up that joint a little bit too. And so I've threaded the saw blade through, and I just wanted you to be able to see a little bit of what this looks like. I'm looking straight over the tube, and I'm just cutting off any excess metal that I can get to, because eventually I'm going to have to use a file to get in there once the whole form is done. So as close as I can get it, the better, but I don't want to accidentally go into the joint. So I have the edge roughly cut off, and I can leave it that rough if I want to. And then the next thing that I need to do is make sure that this top is really, really flat. So I will do that, and then I'll be ready to take the next piece, which I annealed before, and I'll solder this to that. And I'll make sure to solder the inside tube as well. So that'll be the last joint, and then everything else will be cutting things off and cleaning up. So ventilation is on. I'm ready to solder again. I've already put paste flux on the entire thing, and I have medium silver solder pallions now because we have hard on these previous joints. And then I also have some silver solder on the inside edge. Currently that bottom sheet is still a full sheet. You can pre-drill a hole too to make it a little bit easier, but sometimes then the pallions go flying everywhere. So I usually leave that part just a solid sheet, and then I'll be heating around again, and then keeping my heat consistent. So I'm going to still do 2 torches. You can kind of see that rough edge that I left there on the top joint, so that it's protected a little bit more from the heat. So same thing. And again, I'm going to start by preheating. And I'm pretty deliberate about where I'm preheating. I do want to make sure that everything gets hot enough. So you can see that I'm cheating to the middle right away to just make sure that all that heat gets to where it needs to go. And I'm not sure if you can see it in the video, but the paste flux is starting to lose some of its water, and so it's kind of starting to look like toothpaste or something. It's getting like chalky. And then now I can see the color shifts that usually happen with annealing, and so I can see I'm past that rainbow stage in annealing, and now my flux is starting to get really mirror color, so I know that it's getting ready to flow. The nice thing about having those cotter pins is that you can still get that heat underneath it, which I need to be able to get that center cylinder. So I'll get this nice and hot. If I get the top too hot, that solder is going to want to go flying up the wall, because it's following the heat, which it did on a couple of those. Now I've kind of got that heat underneath and really telling it to stay nice and hot at the bottom. Still be careful of your previous solder joints. And that looks pretty beautiful. The inside looks great. I did have a couple of little spots that it went up the wall because I was too hot. If I have enough time to get those solder pallions in there right away, I can try. Ooh, that was a lot of solder pallions. But if not, I just need to pickle and go again. But it's just a tiny little joint here that went up the wall. Or it might have been, I didn't even have the pallions in the right place anyway. So sometimes I like to try to do it while it's all nice and hot. Sometimes it just becomes too dirty to get it to flow. And you'll know if it's too dirty because the solder ends up looking like it's kind of skating all over the surface. If you were using sterling silver, you probably wouldn't be able to keep going at the heat because you could melt the metal. I'm using copper and red brass, and so that's why I was able to kind of sneak that in at the last second there. But I can see that white line all the way around my joint, and I know that the solder joint went all the way around, and I can see it on the inside edge too. So it's good to go. I'm gonna let it sit for a second because it's very hot, and then I'm gonna quench and then put it in the pickle. Remember that if you use cotter pins, I'm using these because they're the same height and they're steel and it's a consistent height. So Fred Finster brought this to us especially, and he was using hairpins, you know, when they were straight up steel, but cotter pins work great too. But remember that they're steel so that they can't end up in the pickle or they'll plate all your work. So I have the finished soldered form, and I just drilled a hole through the middle of that bottom sheet metal, and then I'm going to pierce out as close as I can get to the edge down here without cutting into the top edge. So you need to make sure you keep your saw blade straight up and down. This can be kind of tricky. Just make sure you have enough light too that you can actually see in there, which I don't right now. But keep that blade straight up and down. Cut the center out. I already cut off the bottoms, the outside. And so I have just a little bit more to cut off, and then I am down to hopefully finishing. I'd already checked to make sure that there were no pits and to make sure that the solder went all the way around that seam, especially that part that I kind of cheated on at the end there. And it looks great. I'll be able to know even better now that I've got this excess metal off. And so if I needed to, I can go back and just add some medium solder. But I can really see all that joint looks great. And you can always take like your scribe and go against the edge of the solder joint, and then you'll be able to see it nice and silvery all the way. So I don't see any pits currently. If they were going to come up, they could come up whenever I'm taking the part out of the middle. And so the middle is going to be the longest in cleanup. It's going to require using a file or if you have some flex shaft tools. And then the outside edge, you can use a crosscut aggressive file. You could use a belt sander safely, but I wouldn't go down to the belt sander to where you get to the joint because you'll start messing up the outside wall of the metal. So belt sander is just to get rough stuff off, and then you need to switch to files and sandpaper, sand sticks or sandpaper. So that's where we're at. Hollow construction ring. Did it. I'll finish it, and then you'll be able to see the finished product. So there we have it. Hollow construction ring. You can see the red brass on the outside. I do not like those holes on the outside, so I would put those on the inside of the tube, or introduce them into the design more. And then I have some final sanding to do, but joint looks really clean. Nice thing about putting copper and red brass next to each other, or any alternating metal, is that it completely hides the silver solder seam. So there it is. Good luck.